Hi guys, today we're going to teach you guys how to solve differential equations. First of all, differential equations are equations in which one of the variable is a derivative expressed as dy over dx. Here are some examples. This one is dy over dx equals to x plus x times y. This one is dy over dx equals to x times dy over dx minus 1. This one is dy over dx equals to 1 plus y over x minus 1. Those are differential equations. Then we're going to use a simple question to tell you guys the steps of solving differential equations. First of all, we have this question. So dy over dx equals to 1 over x when x equals to 1 and y equals to 2. First of all, we have to write the differential equation down. And then we separate the variables, gather y on the left side and x on the right side. Then we have to integrate both sides, and then we can solve y in terms of x. Then we can plug in the x, y value given by the problem into the y equation we solved before, and then we can get the volume of the constant c. And then we have the answer. Okay, so now we're getting to a harder problem. So this one is solve differential equation dy over dx equals to 1 over 2 root x. So first of all, we still have to write it down. And the second step is the separation of variables. So in this case, we have to times 1 over x, 1 over y first. So it's like, and then we have to times dx on the both sides, so we get, yeah, that's how we get it. And the third step is we have to integrate on both sides. In this case, the left side is really easy. You can just get it from the formula. So on the left side, it's just ln y. And for this side, we can get the 1/2 first, and we can transform root x into x to the negative 1/2 power. So according to the formula, we can get this. So now it's the four steps is really important here, because when we say ln y, we have to think about e. So we have to use e to get rid of the ln. So we can do this so that we can solve for the constant. And then from this one, we can transform it into y equals to e to the x power to the 1/2 power times e to the c power. As we know, c is a constant, so e to the c power is still a constant. So it's like c times e to the x to the 1/2 power. And because there's no given x, y value in the problem, so we cannot solve for the c here. But in most cases, we have the given x and y so that we can solve for the constant c. And we will talk about that in the later video. Okay, this is the third question. So this question is to solve differential equation dy over dx equals to 1 to the second power over x and y1 equals to 1/3. So for this question, we're going to focus on two things. The first one is the separation of variables, and the second one is to solve the constant c. So the first thing is still we have to write it down. And the second step is the separation of variable. So in this case, we have to times y over y to the second power first, and then times dx on both sides so that we can get this. And the third step is to integrate on both sides. And then solving the integration, we can get this. And after rearranging the equation, we can get this. And the next step is solving for the constancy. So in this case, from the problem, we can tell that when x equals to 1, y equals to 1/3. So we plug in the x and y value here, so we can get and then from our knowledge, we know ln 1 equals to 0, so we can get, and doing some math here, we can get that c equals to -3. So the fifth step, then we can write the answer. So it's like y equals to -1 over ln x minus 3. So that's the answer.